Hello, everyone. Hope you're all can hear me. I hope you're all doing fine, and welcome to this session. I hope you're able to hear me all right. Let me know. Okay, let me know if you're able to hear me. Okay, great. No, that's great to know. Yeah, good evening, everyone. We're all doing fine, and welcome to this session, which is going to be the first of, I think, a 5-part series, I believe. And yeah, we'll just wait for a couple of minutes for other people to join in. I'm sure you have a few more people in this particular cohort. And anytime you have issues with audio, video, let me know. I'll be more than happy to stop and then correct that. Okay. All right. So how are you doing today? You just some of you would have come back from work, I suppose, right? Okay. Yeah, I'm sure you would be. You would have come back from work, and then hope you had time to kind of relax a little bit before joining in, and yeah, just to refresh also. Okay. We will have a break in between so that you can have a dinner break at some point after we finish an hour or so, and then we'll take a dinner break and then come back and then rejoin in. Yeah, this is going to be a 3-hour class. So I'm sure it's going to be a long one, and I want to make sure that you are fresh and energized during this 3-hour session. Okay. All right. We will give another 2 minutes to people who might be joining in, right? So allow me to start this after 2 minutes. So, so just so that we keep the conversation happening. Which of the data structure classes have you enjoyed the most in terms of, let's say, um, the concepts or data structures in general? Which of them have you liked the most in your learning so far, or any algorithm for that matter, data structure algorithm? Any thoughts? Any thoughts? Any comments? Have you worked with linear data structures and nonlinear data structures? I believe, right? Like, for example, let's say boundary trees, boundary search trees, graphs, or for that matter, linear data structures, which would be, let's say, stacks, queues, arrays, right? Which one did you find very interesting in your opinion? Okay. So arrays, you like arrays. Okay. Okay. Any other topics that was of specific interest? Okay. All right. Sorting and searching. So any specific sorting algorithms you studied and that you find was very interesting? Okay. Bubble sort. Okay. Heap. Yeah, heap is pretty interesting too, actually. Mm, right. Did you also study the application of heap in your modules, in your data structure modules? Okay, that's great. Yeah. Okay. So I think we will get started at this point, and let's get started for today's session. And hello everyone, and welcome to this session. My name is Prasad Katti, um, and I'll be handling um, some of these sessions starting today, and essentially around arrays, 2D arrays specifically. And yeah, nice to meet you, all of you actually. And yeah, I hope to have this particular session to be interactive, and hopefully um, I'll be able to essentially share some of the things that I know, and also learn from some of what you know as well. Right? It's going to be a bi-directional kind of conversation. Okay. All right. So let's get started. And so you already know about 2D arrays, right? I would think. I'm sure you would have looked at 2D arrays in at a basic level, right? So 2D arrays. Why would you need arrays in data structures? Can we start from there? I just want to keep it interactive so that it becomes a little more engaging for you as well. Okay, to store multiple data in one variable. All right. Okay. What else? What are some of the, so that's one advantage that you brought about, right? What could be, let's say, a disadvantage with an array? What would be the con? Searching an array is easier. Okay. When is that easier? Can you elaborate on that a little bit? When is searching an array easier? When can you elaborate on that a little bit? Yeah, you're actually right in one way, but I'm just trying to understand when is it easier to search in an array, and why is it easier to search in an array? Are we able to see my screen right now? Okay, allow me to share my screen a little bit here. Okay. How about now? Are you able to see my screen? Okay, great. So that's great to know. So array allows us to store data in contiguous fashion, right? So these are data that's stored in contiguous memory locations, right? So that's where you have arrays. And what is the other aspect of array that you can essentially call out, right? So essentially, let's say you want to do, can you zoom the whiteboard a bit? Okay, no problems. I can. I will actually need to keep the chat window as well open so I can see you interacting with me at any point in time. So allow me to do this just a little bit carefully here. Okay. So how is it looking right now? I have actually enlarged that a little bit. Looks good. Okay, that's nice to know. And I also need to position the video as well better. Okay. First thing is, right, so we have different kinds of arrays. One is the one-dimensional array, right? So 1D array, right? And then we have the, of course, two-dimensional array as well. But before we get there, we will look at why we need arrays, right? So these are contiguous in nature, right? So for example, if you want to store data, they are lying next to each other, right? Say, for example, you have an array of, let's say, 10 elements, right? I'm just making up an example here, right? So if you want to have a data which is co-located, right? Which is, when I say co-located, they are lying next to each other in your memory, right? So essentially, it allows us a very fast access, right? And you can also access them by index, right? So for example, each array has an index, right? So let's say indexes in computer science, they start at 0, right? So we have 0 indexed data structure. So for example, first position will be 0, second would be 1, third would be 2, 3, 4, 5, 6, 7, and 8, right? So like right now, this is an array. Let's make it 10 for the sake of our example. So this is an array which can hold 10 elements, right? So in most languages, arrays are always going to hold, they're typed arrays, right? So for example, an array could be purely of integers, right? Or it could be purely of, let's say, strings, or it could be an array of objects as well, right? But I'm not sure in JavaScript, especially because it is not typed, it actually cares whether we put in, let's say this is an array that is defined in JavaScript. We could actually give it a 1. We could actually give it a string called greet, right? Right. And we could also have something like Boolean, which is going to be true or false, right? So this is going to be possible in JavaScript, not in other languages. I'm thinking we can actually test this out, and then we can take a look at that as well. So coming back to the arrays part, right? These are contiguous in nature. The data is placed next to each other, so we can look at data using their indexes. So random access possible, right? So array at position 4, right? All I can do is, let's say, I can say, assuming this array is having a variable of ARR, I can say I need array at position 5, which is at index 4, right? So, and this one is, let's say this is 5, okay? And if you try to print this one out, you'll actually get 5, right? So the good thing with array is that it is contiguously placed, right? And it provides this random access to data, right? Regardless of the size of the uh, size of the array itself, right? So assume that there are millions of items here in this array, which is a possibility, right? Again, depends on your memory constraints and what kind of a memory that you have at your disposal. That is also going to make it. That is also going to come into the equation, right? So, so given that this is so what would we say? We have random access available. We have let's say we could be statically typed or it could be dynamically typed, right? And when I say statically typed, you have the elements within the array are types. So for example, we could have an array purely for integers, purely for strings, purely for objects, right? So that is typing. But in JavaScript, typing is not strictly followed. If you want to follow type strict typing in JavaScript, you have to go for something like TypeScript. I'm sure you heard about TypeScript, any of you? Yeah. So TypeScript is just another form of JavaScript, but with a little bit more, let's say, provides a bit more structure to the data structures that we employ in JavaScript. Okay, and in any of the other things that you define there. It could be models, it could be objects, it could be generic data structures that we define as part of our. It is stricter than JavaScript, yeah. Yeah, it is stricter than JavaScript, I would say, yeah. Absolutely. Okay. So what happens is that, so again, I'll touch upon that as well. So when we say strongly typed, how does that help us as developers? Any thoughts? When we say it is strictly typed or statically typed, so we don't get type errors when? Okay. All right, so obviously we don't get errors at runtime, right? So for example, for JavaScript, if you purely look at it, could you call it a, let's say, compile language or something else? JavaScript is actually an interpreted language, right? So when you execute JavaScript, it is run line by line, right? So let's say, for example, we have something like, I'm going to go back to my code base, my IDE here, so I can explain that a little bit in a bit of detail, right? So I'm going to make myself a oops. Okay. Okay, something happened here. All right, there we go. Just need to arrange this the first time around, hopefully. Yeah. Okay, so I'm going to call this a some JavaScript file called test.js for our purposes, right? So I'm going to say in this particular thing, let's say const read to hello everyone. So and I can say console.log. I'm just going to go ahead and console log this greet. Okay, console log this greet, and I can have some other thing. Let's say, for example, const a is equal to 1, some other statement, right? Const b is equal to 100, right? And then I can say console.log and a minus b, right? A minus b or something like that. Minus b, right? Okay. So let's go ahead and run this. If I run this right now, what happens is that it is going to give me, it is going to interpret this entire source code, right? And look at it one line by line, and in case there is an error in our code, it'll throw it up at runtime, right? So which means when, let's say, I'm browsing the web page, right, and I'm running JavaScript in the browser, it would, in case it encounters any error, it would be given to me at runtime, right? So we'll not, again, it could be compile errors as well, right? So for example, let's say I'm going to run this particular thing now. I need to go into src, okay, and I'm going to say node test.js. Yeah, there we go. We get this particular thing, right? However, if so right now, if you look at it, we don't have a compile phase. The compilation is happening at runtime, correct? It is going to be interpreted by the Node.js engine, and then the output would be produced, right? There is no compile phase here. So let's say I make a mistake here. So for example, I'm going to say console.log. I'm going to say ABC. There is nothing called ABC here. So I'm going to try to print out this object, let's say. Okay. So if I do this right now, what happens? It actually gives me a runtime error, right? Because until this point, there was no issue. Actually, let me do this. I'll go ahead and then paste this ahead of time. The reason I'm showing this is that, it runs fine until a particular point, and then throws an error at runtime. So essentially, this is where we call it an interpreted language, right? So it is essentially compiling line by line. You see what I mean? We are not compiling in bulk, right? So for example, if you looked at other languages, for example, are you, any of you coming in from, let's say, Java or C++ world? So in Java or C++, they are purely compiled languages, right? So we have a compilation step, and then we have, that compiled code is interpreted by the JVM, right? So that's how it happens. And there was another concept called just-in-time compilation, okay? So a lot of the newer engines are coming up with something called just-in-time compilation. Have you heard about just-in-time? JIT, they call it JIT. Okay, so JIT is something that is done to, let's say, if there is a repetitive code, right, and there are repetitive, this answer is the same, right? The compiler or the interpreter identifies that code block, and it doesn't essentially do the, it just keeps that compiled code in memory or in cache, so that it improves the performance when it encounters the same kind of code at a later point in time, and it uses the compiled code. Okay, so that's how it works. Yeah, you can look up more about it in terms of how it actually improves performance. I think some of the browsers actually employ JIT, the just-in-time compilation as well. Java does that. It did not have that earlier, but with subsequent versions of Java, they actually introduced just-in-time compilation to improve performance. Okay. All right. So coming back to our point, right? I wanted to essentially touch upon this part, and let's go back to the, yeah. So we have random access with arrays. We have, so it's fast. And somebody also talked about searching, right? I think it was, let me check who it was. Somebody talked about searching. Okay, it was Sasen Kumar, right? So you talked about searching, and it is a valid point that you mentioned. Okay, so when is searching very fast in, let's say, when is searching fast in arrays? So searching is fast only when an array, yes, it is sorted, right? Otherwise, it's going to be, so what's the complexity in a when you search in a sorted array? Any thoughts? N log n? Are you sure? Are you sure? No. Order of n, that would be an unsorted array. Best case n, no. Let's take the average case, right? Let's assume that our data is pretty good, and it's sorted. And what is the searching? Yeah, it is log of n, right? Because essentially for each iteration you are dividing the array into half, right? So that's a massive, it's a massive, let's say, advantage optimization. So for example, let's assume that you have a let's say a million elements, right, in your array. Okay, if it is unsorted, what would be your search? What would be your search complexity for, let's say, a particular element? It's going to be order of million, right? However, if it is going to be, let's say, sorted, it would be the log of million, which is going to be how much? How many? That would be 10, I think. Is that correct? 10, or I don't know. So 2 to the power of 10, is it? Or 2 to the power of 20? 2 to the power of 5? No. No. So if you have a million items, right, and you want to search for a certain element, you would be making how many iterations there? That would be log of n, right? So that will be log of a million elements. I'm not sure. If you look at the power of 2's, right, it's the power of 2 to the power of 10 would be how much? 2 to the power of 5 is 32, 6 is 64, 7 is 128, 8 is 256. Okay, 2 to the power of 10 is 1000, right? No, but in computers, you always look at binary, right? You won't do a power of 10. So in computers, it only knows binary. So whenever you do the complex analysis, you would do it in binary, right? So in binary system, that is. Okay. All right. So again, I think it will be about 2 to the power of 10 in my 2 to the power of 20 is a million, I think. As far as I know, 2 to the power of 40 is probably a billion. So essentially, if you have a billion elements, right, in an array, and it's sorted, and you want to search, you'll be making only 40 iterations, which is great, right? I'm saying the max you would be making is the 40 iterations. So that's where the power of, let's say, the sortedness of the, let's say, the array comes in a picture, and also the power of, let's say, the binary search, because if every time iteration is the array is going to be halved, and that's going to give us the power of reducing the complexity big time, right? And that's the, let's say, difference between a very high performance algorithm as opposed to a slow performing algorithm, right? That's where you would have to essentially pay more attention. Okay. All right. Good points, folks. Good that you're actually thinking through some of these things. It's always going to help you. All right. Okay. So coming back to the arrays, right? So let me actually touch upon the fact that how we actually represent arrays here, right? So I'm going to go back to the command line. I'm going to go ahead and increase this one. I'm going to call the node interpreter. Okay. And here, so let's say you want to define an array in JavaScript, right? So let's start with a single dimensional array. So I'm going to say const array underscore 1, and that's for single dimensional array, and it's going to be enclosed in 2 square brackets, right? And you can have anything in between, which are separated by commas, right? So for example, this could be an array of integers, which could be 1, comma 2, and comma 3, or it could be an array of, let's say, roll numbers of students in a classroom, right? It could be anything, right? Again, it could be sorted, or it could be unsorted as well. So if I do this, it gives me an array which is defined, which is holding all our elements on in memory, of course. This is not on disk. This is going to be in memory, right? This is not persisted in disk. So for example, if I, again, that's another thing that you need to be aware of, where, you're actually storing data in memory and storing data on disk, right? So can you tell me the advantages and disadvantages of both? Storing data in memory and storing data on disk. So when you store data in memory, you can access it very fast, right? Memory access is always very fast. And however, if you store that on disk, it has to make an I/O call, the input-output call to an external device, right? Or it could be, again, the external device could be on the same machine, or it could be on a different machine or a network, right? So, and that could take a lot of time. So I/O disk or disk access is always slow, right? And it is expensive, right? However, access to the data in memory is fast, right? But also it comes with an additional expense as well, where you have to allocate more memory or additional memory to store data in addition to the disk as well, right? However, you also want to know that the data stored in memory is also ephemeral in nature. When I say ephemeral, it is not permanent, it is temporary, right? So let's say if I close this IDE, I will lose this data, right? However, if I store this data, let's say on a file system or onto a database, that will be persisted forever, right? Unless there is some data corruption on the database side or from the file system side, right? And the next time I come in, I can always go back and then look it up, right? So that is one of the key differentiators between the data that is stored in memory and data that's stored in disk. The disk is for permanent storage. Memory is for temporary. However, it allows you to have very fast access to your data. Okay, something for you to be aware of and then internalize. Okay, so now if I go ahead and then type this one out, it should actually give me the contents of the array. Okay, so this is the array, the single dimensional array that we were talking about. Okay, and again, we are also talking about types. So for example, let's say I want to do another array here. I'm going to call that ARR underscore, I just call it 1 to indicate it's a single dimensional array. So I can, as I mentioned, this because this is not typed in JavaScript, I can have a 1, I can have a true, I can have a string called greet, right? And this could still be an array in my opinion. Let's try that. Yeah, it is. So there we go. There we go. Okay, we can still have this kind of an array, which essentially stores dissimilar types of elements, right? Dissimilar type of data elements to be precise. Okay. However, if it were to be a typed um, um, array, right, it wouldn't be possible, right? You could only store something like this if it were a typed array. Okay. All right. So this is the single dimensional array. And some of the things that you need to be aware of in terms of arrays, let's say the methods in arrays, right? So, I'm sure you would have looked at it. So let's say I want to add something to the array, right? So I can use something like a push, right? So I can say push, and let me say I'm going to want to push to 6 to this particular data, to this particular array. And what would happen here? Where would 6 be positioned? Yeah, it is going to be the end, right? So I can say array 1, and then we would see the actually push. If you look at it, if you come from, let's say, a stack world, 3, what is 3 here? What is 3 that you're referring to? Okay. Okay, no problem. So So push actually, right, if you've looked at some of our linear data structures from your earlier data structure module, it actually is coming from the stack world, right? So for example, you would have looked at stack. I would have studied stack as well, I'm thinking. Have you studied stack in your earlier classes? Okay, so stack, it is, what kind of a data structure is a stack? It is a first in, first out. Yeah, is it a FIFO? First in, last out. Yeah, FILO or LIFO. LIFO is also fine. Last in, first out, right? Either of them, right? So so there, the push and the pop will essentially come in a picture. But in JavaScript, they have provided that particular functionality in a single data structure for array. So for example, I can use this particular array as a stack as well right now. I can push it, and if I, let's say, if I do a pop, what do you think I should be getting? It would be array1 dot pop, right? What should it pop right now? Should it pop 1 or should it pop 6? It pops the last element, right? So it just acts like a stack here, right? So in JavaScript. However, if you want it to be, let's say, a queue, I think you can also act as a queue. They have something like shift in JavaScript. So, let's say array1, something called shift, if I'm correct. So shift, let's say 7, that, right? Okay, let's see what I get in array1. Okay, 7. Okay, it made it. Okay, I'm not. So there is something like unshift as well. So probably unshift actually puts it at the beginning. So let's say array1 dot unshift, and this is going to be, let's say, 100. Okay, or did we get? Okay, it actually puts it at the top, right? Look at that. It actually puts it in the front of this particular array. Okay, unshift. Okay, super. So another thing, right? So you would have learned about the destructuring part, I would think. Is that correct? Array destructuring or the object restructuring, something that we would actually look at as well as we go along. So let's say right now, if we want to type array1, that is array underscore 1, I think. Okay, there we go. So so if you want to find the min of this one, right? So I'm going to say const min is equal to, this is going to be math dot min. I think, I hope this is correct. And I can just destructure this particular thing right now like this. Array underscore 1. Okay. If I do this, it should give me the min. Hopefully that's going to be 2. And if I say min, it gives me 2, right? So essentially what destructuring does, it spreads out. It's not destructuring, it's probably the spread operator. I think that's the right word. Destructuring is slightly different. So this is the spread operator, right? It's going to spread the elements of the array and then try to find the min out of that, right? So ideally, min, if you've looked at it in JavaScript, so it would actually say math.min, give some elements, let's say, for example, 2, 3, give you 2 as well, right? However, here, this will be more than 2 elements, right? So right now we have 5 elements. So that'll allow us to spread the operator, use the spread operator, and then find the min here. Okay, so that's one more thing that would be very handy when we do the actual problem solving. Okay, so can you tell me here what would be the complexity of this one, the math.min function here? Any thoughts? That would be order of 1. Is that correct? Would that be order of 1? What do you think? So this would be actually order of n here, because this is an array, right? And min function is actually going through the entire array and trying to find the min. So this is actually order of n, right? Okay. All right. So let's get started. I just wanted to give this brief background before we get started with the problem solving part, just to essentially refresh our memory and take it forward from there, right? So let's get started with our first problem. Any questions or any thoughts so far? Okay. So I need to drag this one out so I get to essentially see things clearly. Okay, there we go. So the first problem is going to be about lucky numbers. So we have an m by n array, right, with distinct numbers, importantly, and we need to return numbers. Uh, we need to return lucky numbers, right? So lucky number is an element of the matrix such that it is the minimum element in its row and maximum in its column, right? So let's take an example here. I'm sure there is one here. So if you look at this one, right, we have a 3 by 3 matrix, right? And we have these elements, 3, 7, 8. Let me actually bring up my whiteboard as well here. Okay. So if I look at this, we have an array, right, which is going to be 3, 7, 8. Right? Let's actually jot it down here. So we have, this is going to be an array. Okay, give me a moment. So we have an array, right? So that's called 3, 7, and 8. And we have 9, 11, and 13. And the last one is 15, 16, and 17, right? Okay. So what do you call them lucky number? So lucky number is something that is actually the smallest in the row and highest in the column, right? So for example, what do you call a lucky number? A lucky number is an element such that it is the minimum element in its row and the maximum in its column. Okay, so let's actually go back to the example here. If I go back to the drawing board. So right now, if you go by row, right, we want to find the lowest number in this row, right? So what is the lowest number in this row? It is 3, right? The minimum number, right? And in this one, it's going to be 9, right? And in this one, it's going to be 15. Oops. Right? And also, we need to find the highest element in each column, right? So in this particular thing, what is the highest element here? This is going to be 15. This is going to be 16. And this is going to be 17, right? So do we have any common element which is occurring in that particular row and column, right? So we see that 15 here is the smallest in this particular row, right? However, it is also largest in this particular column, right? So we see this being a common link, right? So that's one of the lucky elements here, right? Because right now 15 is the smallest in its constituent row, which is going to be row number 2, if you consider this one as row 1, 2, row 1, and this is row 0, and this is going to be column 0, column 1, and column 2, right? So 15 is the smallest in row 2, and it is also the greatest in column 0, right? And because there is an intersection here, we actually say 15 is the lucky number here. However, if you look at other numbers, can you find any other number which actually follows the same pattern here? If you look at, let's say, 9, it is not the smallest in its number, but it's not the smallest in its column, right? It is not the greatest in its column, right? And similarly, let's say if you take 13, 13 is not the smallest in its row, so that essentially rules itself, right? Rules itself out, right? And let's say you take 3, it is the smallest in the row. However, it is not the greatest in its column, right? So it is the smallest here, but here is not the, if you go from here to here, it is not the greatest, right? So that's why they will not qualify as some special numbers, right? Is that making sense, folks? Okay, great. So what we have to do here is that we have to first find out the minimum in each column, right? I'm sorry, in each row. We have to traverse in each row and then find the minimum in each row and store them in some temporary, let's say, storage. And then we go through each column and find out the maximum in that particular column. And if that maximum is found in the temporary storage, then we can say that is a special number. Okay? All right. Yeah, right now 15 is a special number. Okay? Make sense? Any thoughts, folks? Okay. All right. So so if we had to actually do it in a brute force way, right? How would you do it essentially? You would first take essentially the elements from each row, right? Find the let's say storing and comparing. Yeah, that's definitely there. Yeah, you first make sure that you find the minimum in each row, and then eventually you go in a row in a column wise function, right? And then find the maximum, and then if the maximum is actually there in any of the minimums that we recorded, then that is a special number, right? So let's actually go back to our code base and then try to set this one up. Okay. It's not a special number, by the way, it's a magical number. Right? I was using an incorrect essentially terminology for that. So let's go ahead and then start this one out. Okay. I'll go back to my IDE now. I'll close this one. And I'll call this, actually, I'll create another one for today's session. That'll be part 1, because as we move along, there'll be multiple days in which we'll be solving multiple problems, right, pertaining to that particular day. So I'm going to go ahead and then make it part 1 here. And I'm going to create a new file. I'm going to call that find underscore magical number. Okay. All right. So let me collapse this a little bit. So in here, I'm going to define a new function. I'm going to call that const find magic underscore number. Okay, and this is going to get. So in the problem statement, they actually said, gave a few things in terms of um, getting the data from the command line and all that stuff. Ideally, if you go to the interviews, they will not place so much of information in the data capture part itself. The focus would be more on the problem solving part, which is going to be the uh, meat of that discussion, right? So they will, if there is a problem where, it says, you have to accept the data from command line or for some other place, you can always say, you can assume that, you will design in, let's say, a method which will accept these as input parameters, right? So in this case, what I would do is I'll accept the number of rows, right, and number of columns, and the matrix itself, which is going to be the numbers. I'm going to call that numbers. Okay, it's going to be an arrow function. Okay. Super. So the first thing is I'm going to, so every time, generally the way I look at these problems, right? The first thing I want to do is, I'll check what I need to return from this number, right? From this particular method, right? So I'm going to select magic number. Magic number is equal to, I'll just initialize it to some number. It's, let's say, a non-existent number. It's something like -1. It could also be something that's imaginary. So for example, infinity or negative infinity or something like that, right? And then I can go ahead and say at the end, I can just go ahead and return this number, right? And the magic number to be precise. Okay. So in between, we have the logic to actually go ahead and find out what the magic number itself is. Okay. All right. So anytime you define a method, right, that actually, or a function for that matter, which provides us some input, output based on certain input, we'll always have a validation logic, right? So we can always have a validate block here, right? So I'm going to say validate data, validate input. Okay. That's going to be one of the key things that I would do, right? And once the validation is done, then I can go ahead and then do the rest of the computation. So we'll come to the validate block at some point after we do the basic logic itself in terms of setting up the algorithm. So that's one of the things that you would do in your interviews. So when you start coding up, right, you would have a thought process to do the validation, but you can look at the initial flow first and then start looking at the validation at a later point in time and subjecting it to different kinds of inputs, right? So, and then look at the, let's say, the reliability of your algorithm itself in trying to come up with the right answers, uh, regardless of any kind of input, right? So that's one of the things that you would be essentially focusing on. Okay. So what do we do first? We will, so let's actually go ahead and then get this data here itself. I'm going to go back to the actual data that we got. So that was this one. Let me collapse the sidebar. I think this is better. Okay, so this is going to be our 2D array, right? We do this. Yeah, I missed the comma here as well. Okay. Okay. I forgot to tell you another thing, right? So we discussed the 2D single dimensional array. How do we represent 2D arrays in JavaScript? I think that's something that we didn't talk about. So let me go back to the, go back here. So, node. So if I want to define a 2D array, it would be something like this, const array underscore 2. Okay, and this is going to be equal to an opening brace or an opening square bracket, that is, and I can go to, and then I can define the first row in our 2D array, and I'm going to call that, and which means I have to open another square bracket here, right? And 3, 7, and 8, close it, and put a comma, and go to the second row now. It's going to be 9, 11, 11, and 13. Okay, and the third row, which is going to be 15, 16, and 17, right? This is how you would define a 2D array, right? So now if I print out the array 2, it should give me the 2D array, right? So I can say array underscore 2, and let's say I want to access the first row, right? I can say array 2 at 0, it will give you the entire row here, right? And if you want to access the first element in the first row, you would be doing something like this, right? Get 3. Similarly, if you want to access the last element in the array, you would go to the last row and the last column, right? There we go. There we go. All right. So this is how we would do represent 2D arrays in JavaScript, of course. Important to know because different languages use different ways of representing 2D arrays, right? So it is going to be language specific, right? So in our case, since we're using JavaScript, we would be representing it this way. Yeah. Okay, there we go. Super. This is going to be our input data, right? I'm going to comment this one out because otherwise it's going to give us some compilation errors. Okay, there we go. Okay, so first thing we want to do is we want to go row by row, right? So we can go with the first row. We start processing for each of the rows and find out the minimum in each of the rows, correct? Okay. So okay, let's go ahead and do that. So let's assume that m is the number of rows. So I'm going to actually open up a for loop here, and that's going to run with, let's say, an index of I is equal to 0, which is going to be the first row, and until we reach the last row, which is going to be row number m, right? And which is going to be less than m because we cannot equal to m because that will be out of bounds exception, right? Because we start at 0, we always end at the length minus 1, right? In arrays, when dealing with arrays, right? So let's actually go ahead and then console log the first element, right? So I'm going to say const row is equal to, this is going to be, let's say, numbers at I, right? So what should it give us? It should actually give us the first row itself, the entire row, right? So let's actually type this one out, right? So I'm going to const, oops, no, not const, console log. Okay, all right. Let me go ahead and exit from here. Okay, if I say node, find magical numbers. Okay, I need to be in part 1. Node, find magical numbers. Okay, it should print us all the rows, right? Interestingly, it is not doing that. The reason is that we're not calling this function. Okay, classic mistake, right? So I need to call this function, right, with some data. So let me take this one at the very end. Perhaps this. So, and I'm going to call this const input. we go. Oops. I would say console.log and find magical number. And I'm going to call this with this particular input. Okay, let's see what happens now. Hopefully it's going to run. Interesting. It's saying, oh, yeah, thanks for that. So it has to be, that's where the validation part will come into picture, right? So yeah, 3, 3. There you go. Actually, to avoid that, right, you can always default some of these things. Again, it's I'm showing this as an example, maybe not relevant to this particular case, but in certain cases, I mean, it will be looking at some of those cases as we move along in subsequent sessions, where we'll be looking at recursion and some of the advanced problems related to, let's say, dynamic programming and stuff like that. We will be defaulting some of these values. So, for example, I can say m is equal to 3. Here n is equal to 3, right? And I can always, I may not necessarily provide these things, right? So if I do this, hopefully it's going to work. -1, interesting. I don't think it actually took that. Let me actually go ahead and then give this 3, 3. Yeah, there we go. We get all the rows, right? So essentially, what we're trying to do here is that we are trying to process each row, right? So let's actually go ahead and continue doing that. I'm going to comment this one out for now. So inside of here, I want to find the, let's say, the min in this particular row, right? So how would I do that? I can say, I can use the math function, right? I can say math dot min, right? And I can go ahead and then use the spread operator here, right? So I'm going to say dot, 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 and row, right? So this should give me the, yeah, number size also correct. Yeah, that's true. Right? So this is going to be, yeah, I intentionally made sure I put row here just to make the code more readable. And this is going to be also something that's going to be important when you do coding in your interviews, right? So you got to keep it very concise, at the same time readable, right? That way it'll help you think with a lot of clarity when you do the coding as well, right? And it'll give the interviewer a sense that you're actually thinking through and then being very meticulous in your approach, right? Okay, so I'm going to say this is going to be a so some min element, right? So I'm going to call that const min underscore element. So we'll do this, right? And I want to store these min elements, right? So I'm going to say I'm going to maintain some temporary storage for this one. I'm going to say const temp array, an empty array to begin with. And I'm going to go ahead and then push this particular thing to the temp array, right? So I'm going to say temp array dot push an element. Okay. So at the end of this, we should have a temp array with all the min elements for each row, right? So let's go ahead and print this one out, right? So I'm going to say console.log temp array, and let's see what happens. I'm going to go ahead and remove this one. The reason it was not working was that I don't know. I was thinking it would probably work here if I give the defaults, and apparently it didn't work for some reason. Maybe the positioning of the of the of these numbers itself, if they were at the end, probably would have taken it. Since numbers is at the end, it's not taking it. Okay, so let's go ahead and then run this one now. So yeah, there we go. We get as expected. Given the input that we're working with, 3 is the minimum in the first row, 9 is the minimum in the second row, 15 is the minimum in the third row, right? So we got the minimum part sorted out here, right? And next, what we want to do here is that we want to go to each column and scan the array and then find the maximum of in each column, right? So what we'll do, we will go ahead and scan the array column wise, right? Column wise, and determine the max, right? Okay. So in order to do that, since this is a two-dimensional array, I would need a 2D array, a nested loop, right? So I'm going to open another for loop here, right? So let me actually minimize the terminal so that you can see the entire thing, right? Okay, so I'm going to say open another terminal. I'm sorry, open another loop, right? I'm going to, oops, for let, I'm going to call this J here, okay? It's going to be in my outer loop, right? I'm going to start at J is equal to 0, right? And since I'm going to be going by column wise, my outermost variable will refer to the column here, right? So I'm going to say J less than the column, which is going to be n J plus plus. Okay? That's going to be my outermost column. And the inner loop will go through each element in the column, right? So then that's going to be for let k is equal to 0, k less than the number of rows, which is going to be m, right? Then k plus plus. All right. And remember, we also need to define a maximum, right? So let's actually, since we need to define it, we need to identify the maximum for each column. We need to initiate a maximum number, right? So I'm going to say let max element is equal to, I want to set it to negative infinity, okay? All right. So I'm going to say, I'm going to first access the first number, right? So the first number here is going to be const element, and this is going to be equal to, let's say, numbers at index k and index j. Okay? Because we are actually doing it in column-wise fashion, right? And then we want to check if this number, which is at this particular index, is greater than this, right? If it is greater, we want to replace this with in the max element, right? So I'm going to say if numbers, if element, since I've already extracted it, is greater than max element, okay, we want to assign the max element, right? So max element is equal to element, right? Okay. Super. So we will do this for each of the columns, right? And at the end of this particular thing, we can always check, right? At the end of this particular inner loop, we can always check if the, where is this particular thing? Okay, the match number. Okay, we have a problem here in the sense this is not properly closed out. So we have a closing bracket for this one. We have a closing bracket for this one. We don't have a closing bracket for this one. Okay, I think now it's looking good. Okay, there's a missing flower braces, so I just introduced that. So we should be good there. So at the end of the for, we can always check if the max number is present in the temporary array, right? So for example, this is our inner loop, right? At this point in time, it would have processed one column, and it would have found out a particular max number in that column, right? So we can say if temp array actually has this particular max element, right? So I'm going to say, I'm going to use the includes function here. I'm going to say includes max element. Okay. Then we have found the number, right? So we can say return magic number. We don't have to look any further. Okay. So otherwise, it will continue to loop through the entire array, and then finally, if it finds out something, it'll return here. Otherwise, it'll return the -1 as the magic number. Okay, so that is the overall logic that we want to look at. All right, so let's actually go ahead and run this and see if it actually works fine right now. Okay, so we can actually put some number here, some console log, of course, console log. Yeah. Okay. Super. Let's go ahead and then test this one out. Okay. Say node find magic number. Says found magic number is 15, but how come it's coming as -1? I think it is falling through here. Essentially, it is coming out of this one. It is. Yeah, correct. But ideally, because we are doing a return of magic number, it should have broken here, right? It shouldn't have even reached this code block, ideally, right? Yeah, maybe we could do this way. For example, let's see, match number is equal to max element. Okay, and we can say break. If we say break, would that work? If we say break after this, that could also be another option that we have. So it should break out of this for loop. Yeah, let's see if that actually works. Okay, fingers crossed. Okay, there we go. We got 15 here, which is correct, right? So this is one of the things that we had, the debugging code. Okay, so looking good right now. Okay, so one of the things that we also talked about was the validation point, right? So typically, in most let's say non-trivial applications, the validation can be very complex at times. Okay, so you can actually externalize it by just having some method here, let's say, that says const validate data, validate, right? And it's going to give you that particular thing, m comma n, and same the numbers array, right? So you can do some validation here. Okay, so this is how we can do that, and then we can go ahead and call. This can either say true or false, right? If it returns true, then you can go ahead and then do the processing. Otherwise, you essentially stop the processing and then say it is a problem, right? So in this case, what we can do here, though, we can check if the bounds are the same, right? So for example, I can say if the columns or the rows are within the bounds, right? So I'm going to say const oops, row underscore bounds check. Okay. And what do we do here? We check if m is greater than 0, right? And I think there was some highest value that was given in the example, probably 10. So let's consider that as 10 for our practical purposes. Ampersand m is less than, say, 10. Okay. And of course, the number of rows also in the matrix has to be equal to m, right? So I'm going to say numbers dot length is equal to m. Okay. All right. And similarly, I can have a check for column as well. So I'm going to call this column bounds check. A bounds check, yeah. It's going to be n is greater than 0, n is less than 10. I'm just putting in some random numbers. And numbers at, I'm going to call its numbers at 0 dot length is equal to n. Okay. That's the number of columns that each. Okay, number of columns. So, and then we return true only when both of them are true, right? So I'm going to say return all bounds check is true, and row bounds check is true as well. Okay, only if these two conditions are true, then we return a true. Otherwise, we return a false. Okay. So we can go ahead and then call this one here right now. So before we go ahead and then do the processing, we can say if, let's say, not validate, if the validation is false, and I'm going to pass the same numbers here, m and n in the numbers, then I'm going to say, instead of say return magic number here, return magic score number. All right, super. So this is how we would do that. Hopefully this is going to work. Let's actually give it a shot. We'll give it a shot with the, let's say, yeah, still works. Validation is looking good. And what else do we have? Yeah, we can also try it with a number, which is not in, let's say, if I keep only 3 and 7 here, right? And it should give me a negative infinity right now. Yeah, it gives me a -1, which means the validation is working. You can also put a, let's say, a comment here saying that console log input validation failed, right? Okay. So if I do this one more time, there we go. Input validation failed. So it's just, you know, abruptly stopping this further processing here, right? It doesn't go to the actual processing logic. Okay. All right. So that's the first problem, and if you look at the complexity here, we are actually going through the elements. Um, we have we're going through the entire set of elements, right? So, for example, in this particular case, we're going through all the elements, right? So, yeah, if we consider m rows and n columns, that would be order of n by n. Since I think it is not an n by n matrix, they said m rows and n columns in the problem statement, I think. So that'll be m by n, right? So the complexity here would be m by n, and what would there be any space complexity here? Because we are using additional space to store our minimum array, right? That would be the number of rows, I would think. Yeah, that would be order of m, correct? So this temporary array, it would be having m elements at any point in time, right? Because we are passing through m rows, and we'll be having m um, minimum numbers, right? So that'll be order of m, the space complexity. Okay, makes sense, folks? Is that okay? All right. So I think what we'll do right now is it is about 9:20, and we'll take a quick dinner break, right, for you to come back refreshed and energized, and take on the next few sets of problems. Make sense? So what do you want to come back? 15 minutes. So that would be nine. That would be nine. I will share the code at some point in time. Not a problem. Okay. So nine. Can we come back by 9:35? Okay. So let's come back by 9:35. We'll be back 9:37. Okay. Let's do that. Hello, everyone. Can we get started? Is everyone back? Okay. Can we get started? I hope so. Hope you had finished your dinner break and we're good to go. Can we get started? Okay. All right. Let's go to the next problem. So essentially, it is something to do with, again, two-dimensional arrays. So we have a shoe company or footwear company where a pair of footwears are packed, but some boxes have been packed with an extra footwear, right? So generally, a box would have two pairs or one pair of, let's say, shoes, right? Which would be the right shoe and the left shoe, right? And in this case, it is having, okay, allow me to share that. Hmm, share screen. Okay, is that looking good right now? Is that looking good? Okay. All right. So essentially, what's trying to say was that we have another 2D array problem where we are given um, you know, a problem related to the footwear, right? So we have in a footwear box, right? We would get a pair of shoes, which would be a right shoe and a left shoe, right? But in this case, what's happening is that there is an extra um, footwear, right? Which is essentially the odd one out, right? So for example, it could have a footwear with, let's say, two numbers. One is 8 and 8, other one would be a 9, which would be the odd one out, right? So likewise, we need to find out, we need to repair these boxes, and whenever there is an extra one, which is the odd one out, we need to repair with the other matching number as well, right? So for example, let's take one of the exams that has been given here. I'm going to go back and then this is 338,989, right? So let me go up a little bit here. So we have a pair of footwear boxes. So it was 338, and I think it is 9, 8, and 9, and 15 and 15, right? So this is the data that we have got right now, right? So if you look at this number, right, this, if you look at this number right now, so we have a box. This row can be treated as a box, okay? This row can be treated as a shoebox. This row can be treated as a shoebox, right? In the first shoebox, we have an extra pair here, right? Which is going to be this one, because 3 and 3 are matching pairs. We can look at them as the perfect box, right? In the second row, we have this one as the odd one out, right? And 9 and 9 become the perfect box, right? And the last row, we don't have any extra shoe, so this will constitute a perfect box, right? So in the first one, we have an odd one out in the form of 8, right? In the second one, we have an odd one out in the form of 8 as well, right? And so essentially, these are the one which are unmatched, right? And we also have the matched pairs, right? So for example, we have 3 and 3, which is matched. We have 9 and 9, which is matched. And we have 15 and 15, which is matched as well, right? So these can be part of our final output for sure, because right now these are matched. However, we also got some unmatched numbers. We can go over them and find out that 8 and 8 can also be matched to come up with another matching box, which is going to be 8, 8, right? So finally, when we repair these boxes, right, instead of 3 boxes right now, we will have 4 pairs, right? Which means we have 4 boxes right now. So which could be 3 and 3, 9 and 9, 15 and 15, and finally 8 and 8, right? So this is what you would get when you process this array with some with matched pairs and some with some rows with unmatched pairs, right? So this is what the problem statement is all about. Okay, so how would you go about this? Okay, let me explain this one more time. So typically, right, let's say you buy a pair of shoes, right? You will have, let's say your shoe size is 8, let's say, right? Or 9 for that matter. You'd get 2 pairs, right? Which is essentially 9, 9. This would be a perfect box, right? Right? Otherwise, let's say if you had something like 9 and 10, right? This would be not a perfect box because let's assume that this is a left shoe, this is a right shoe. The right shoe is 10, left is 9, which is not what you want. You want both of them to be 9 and 9, right? That's when you would be comfortable buying that box, right? Okay. So in this particular problem, what is happening is that each shoe box, right, is containing 3 shoes, not 2 shoes, right? So the shoes could be 9, 9, and 8. So there is an extra shoe which is not matching. Okay. All right. So what we need to do is that and like that, we have multiple boxes like that. So for example, I gave an example of 989. There could be other examples, say for example, 3, 8, and 3, right? Okay. So from here, assuming our input that needs to be processed only has 2 boxes, right, with 3 shoes of course, we need to process these such that we actually give repair. When you say repair, we essentially put right pairs in their individual boxes, right? So we get 9 in each box, in one box, right? 9 and 9 in one box, and likewise 3 and 3 in one box, right? However, we also got 2 individual shoes, right, which is 8 and 8, right? And if we pair them, we also get another complete box, right? Perfect box, right? So finally, our answer would consist of this array and, of course, this array as well, right? So that's what we're required to find out. And in this case, we also had another row, which was 15 and 15, right? Since it is already a perfect box, we didn't have to do any processing on that. Okay. So our final answer would contain 3 and 3, 9 and 9, 15 and 15, and 8 and 8. That's what I was trying to explain. Okay. So is that, are we good to go? Or do you need any further explanation? Okay. Super. So how would we go about this? Let's actually discuss how we can go about solving this problem, right? So we have, so what is the first number here? 9, 8, 9, right? 9, 8, 9, right? And then we also have another number called, was that, what was the other number? I forgot about it too. 9, 8, 9, and it was 3, 3, 8. Okay. So this is going to be 3, oops, be 3, 3 and 8, and 15 and 15, right? So these are individual rows in our two-dimensional array, right? So this can be, let's say, taken as a row, right, which is essentially a unidimensional, single-dimensional array. This could also be taken as or considered as a row, and this could also be considered as a row as well. Okay, all right. So the first thing we can do here is that, let me actually move this. I hope I can. No? Okay. So first thing we can do here is that we can try to go through each of the rows, right? Process each row, right? And find out the matched pairs and the unmatched pairs, right? So for example, if I process this row right now, so what would be the matched pair? The matched pair would be 9 and 9, correct? Okay, this is going to be the matched pair. Right? And the unmatched, we also look at the unmatched pair, which is going to be 8. Right? Okay. So for each, when you process each row, we return these two outputs. So for example, there would be a matched pair, and then there would be the unmatched pair. Right? Unmatched number, actually, or unmatched shoe, I would say. It's not a pair, it is just a single number. So the pair would be that, 9 and 9 here, which is a pair, right? And similarly here, when you process this row, oops, you would get something like 3, 3 and 8, which is going to be the unmatched number, right? And likewise here, there is no unmatched number. We straight away get 15 and 15, right? So after processing all the rows, we have this matched pair, right? Okay, we can take this one and add it to our final output, right? So let's say our final output is, oops. Let's say I just define the final output here. So right. So the final output here would be, obviously after processing each row, I would add the matched pair to the final output. So essentially 9 and 9, right? 9, 9. And of course, I would also have an unmatched pair. And I will actually use this particular thing to add it to the unmatched pairs as well. So for example, I would have, so this one would be the final output, which would contain the matched pairs. And this one would be again 3, 3 and 15, 15. Right? So this is going to be the final output after processing all the 3 rows. However, we still have some unmatched numbers, right? If you recall, from processing each of the rows, we are returning 2 values. One is a matched pair, the other one is the unmatched number itself, right? Which is, in this case, is 8. In this case, it's 8. And in this case, we have no matched number at all, right? So then we need to go ahead and take these 2 unmatched numbers, and then add it to another data structure, right? We essentially add them to another array, and that's called an unmatched pair, right? So this is going to be another pair like this, right? And then we process this again, just like before, right? So we have processed the entire array, but then at the end of processing all the rows, we get some unmatched values as well, and then we try to reprocess them. Okay, so and then add it to the final output, which is going to be again a plus of 8, 8. Okay, so this is going to be our final output: 9, 9, 3, 3, 15, 15, and 8 and 8. Okay, so I think it'll be much clearer as we go ahead and then code this one up. So in case if you are not fully on board with the solution, again, bear with me here. Once we start coding this one up, it'll be it'll be much easier to grasp and simulate this. Okay. Okay. Okay, so let's get started then. I'm going to go back to my IDE. All right. Okay. There we go. So I'm going to call it find pairs, I would think. Right. Okay, there we go. So let's go ahead and do this. I'm going to define a new arrow function. I'm going to call that const find underscore pairs. And this is going to get a matrix, which is going to be a two-dimensional matrix, right? Which is going to be essentially a row containing the shoe numbers, right? Okay. So what do we want to do here? As we process each row, we want to find out, or rather, we want to record the matched pairs and the unmatched pairs, right? So we will define two arrays here. I'm going to call that matched pairs. It's going to be an empty array to begin with. Okay. And I'll also have another one for unmatched pairs. Okay. All right. Okay. So what do? I want to process each row, right? So I'm going to employ the for each loop here. I'm going to say matrix dot for each. Okay. And I'm going to say this is going to be pair or row. I'm just going to say row here. Okay. For each row, what I want to do, I want to find a pair, right? So I'm going to say, I'm going to define another method, and I'm going to call that find pair, right? Not find pairs. It's going to be find pair. I'm going to pass that the row, all right? Okay. So what is it going to give you? It is going to give me a set of another array, right? Which is going to be either a matched one. So remember, when we process each row, right, we will get a matched pair and an unmatched number as well, which is also going to be either an array or, yeah, most likely would be an array, right? So we'll see. So essentially, when I process each row, I want to get these two things back as return values, right? So I'm going to go back here, and I'm going to assign it to a set of numbers, okay? And I'm going to call that matched and unmatched. Okay. All right. So what I do, first thing is I want to check if the matched is not empty, right? So if the, okay, I think I made a mistake here, typo, I made CHED, okay. Okay, if the matched is greater than, length of that is greater than 0, right? So if, actually before that, right, let's actually define what is coming back from here, okay? Let's actually define this one. So I'm going to go up here. So define another arrow function. I'm going to say const find underscore pair, right? This is actually find underscore pair individual. Okay, it's going to be an arrow function, and this is going to get a new row, right? Okay, find pair, and this is going to get a row. Right? All right. So in here, for each row, I want to find out a matching pair and the one which is not non-matching, right? So I will make use of a an object here to find out how many number of matched items are present. Every time the matched item is 2, I am sure that it is a match, and I can go ahead and then put it back in the results, right? So I'm going to say const pair items equal to this is going to be equal to an empty object, right? And okay, and I also want to return the matched results here, right? So I'm going to say const matched pair, matched pair, and this is going to be equal to an empty array. Similarly, I want to return the unmatched as well, right? So I'm going to say matched here. Okay. All right. Remember, if I go back to the diagram that I was talking about, we are trying to return these two values from here, right? So first, we are processing each row, and from each row, we are trying to return these two values, okay? Important to understand that. Okay, so what I do, I actually iterate through the entire row. So I'm going to say row dot for each, right? And in this case, I'll get an item, right? Each item, and I can get to this additional pair of braces. For each item, what do? I will check if it is already found. How would I know? If it would be found if the paired items is already there. Right? We are actually maintaining this particular entity here, right, to record the occurrence of each number in that row, right? So I'm going to say if paired items is already having this item, so I'm going to say if pair items okay, is already having an item, right? This particular item to be precise. So what do? I'd say paired item plus equals 1. I'm going to increment that, right? Otherwise, I'm seeing it for the first time. So I'm going to initialize that to 1. I can say paired items of item is equal to 1. Okay, so this is what I'm going to do. Right. So for the row that is being passed here, I'm going to essentially go over that entire row. So essentially this row would come up something like this, right? So this row would be something like 9, 8, 9, right? This would be a row, right? So I would go over each row, each item in that row. So for example, let's say 9 is the first element. I can say if paired items is already containing 9, it is not containing 9. So I set it paired items for 9 to 1. Then I go to 8. Then the same thing happens. And then I go to 9. I come here. It is already present. I increment that to 1. Right? So right now, I've processed the first row. Right now, my paired items would be having something like this. So for example, if I have to give you a pictorial way of looking at this, right? So we would have 9, 9:2 and 8:1. Okay? This is how it would look like right now after processing each row, the first row, this particular row. Okay, important that we understand that. Okay. All right. So now we have processed the first row, right? And then after processing this, we need to essentially pair them up, right? So I'm going to go over this paired items now, this particular object. I'm going to use the object function or the uh, object reference, and I'm going to iterate on the keys, right? So the key here would be the item itself, right? So I'm going to say keys of paired items, okay? And I'm going to map, I can either map over them or I could do a for each. I think both of them should be fine. So for each is good enough actually. So for each item, so I get the item. Okay. For each item, what do I want to do? I want to pair them up, right? So I'm going to say if paired items of item, right? If this is equal to true, then yeah, if this is equal to 2, then we have found our pair, right? So what do? We push it to our match results, right? So I'm going to say matched pair dot push. Okay. And we're going to push an array to this one. So this is going to be item, comma, item. Right? Else, we're going to push it to our unmatched pair, right? So I'm going to say unmatched pair dot push. I'll be passing only one of them. I'm not going to be passing the array. I'm just going to pass it back this particular number. But this is already an array right now. I'll just pass a number here. Okay. In this case, I have to pass an array because it's a tuple. It's not a singular element, right? Okay. Aradhya is asking something. What is it? I missed that question. What is the question here? Clear? Okay. Super. So, and after this, what we can do is that we can just go ahead and return these two elements, right? So I'm going to say matched pair and unmatched pair. I think we're good here right now. Okay. So after this, we're getting this and this right now. Okay. All right. So now I'll go back to the main function, which is going to be the find pairs, right? So I got the find pair, the output from the find pair. So what I'm going to check here is that if any of these elements, any of these return items are, the length of that is greater than 0, right? So I'm going to say if matched dot length greater than 0. Okay. What do? I want to push this result to this matched pairs, right? So I'm going to say matched pairs dot push. Okay. I want to essentially use the spread operator here. Remember, we're getting the output like this, right? So for example, 9, 9, 9, 9, 9, and this would be in an array. It would be something like this, right? So I don't want to, because this is already an array, I don't want to make it a 3D array, right? So I will say I'm going to go ahead and use the spread operator here, right? Oops. I'm going to use the spread operator here, and essentially it's will give the final output like this. Okay. Else, what do? I'll say unmatched pairs, not push, and I will also do a spread operation here. Okay. So this would have come here as 8, right? And I just want to make sure I destructure this. Line 41, where is that? This one. This one is not needed. No, why? We need that now. We have to process each row, right? We have to process each row, right? Okay. Yeah, this is because the terms and the variables that we are using here, they kind of match in both here and the find pair. It can get a little bit confusing actually. So we just had to be a little more attentive here. That's all. Okay. Okay. So let me go ahead and then erase this one. So we got the matched pairs and unmatched pairs. So right now we have processed all the rows. So if I go back to this diagram, we have processed all the rows, right? And the end of it, we are getting this output, right? So this 9, 9, 3, 3, and 15, 15, correct? We're getting that. And we also have an unmatched pair here, right? So which is 8 and 8 from here, right? So which is what we are actually we are actually storing, or rather keeping track of here in this particular array here, right? So we have processed all the rows. Now we need to process the unmatched pairs, right? So what we can do here is that we can say if unmatched pairs, this one dot length is greater than 0, we will call this find pair again, right? So I'm going to say const matched unmatched find pairs, find pair, and it's going to be the unmatched pairs now. Okay. And finally, we need to push that to our matched pairs, right? So I'm going to say matched pairs dot push. This is going to be the destructuring of the matched pairs. Okay. And what do we return here? Where is my last race? So over here, we'll just say return matched pairs. And this should return us this particular value here, this entire final output. Okay? Unmatched has to be empty at the end of it. Otherwise, we would have an incorrect data set. It is quite possible it might be, it may not be empty. It depends on the data set that we are processing, right? There might be some times where you have, let's say, uneven number of rows, right? Odd number of rows. In that case, it is possible that you will have one odd man out. Okay, it is possible, and matched could be non-empty. Okay, all right. So let's actually take this first pin. So we came here. Okay. All right. Let's actually do a dry run here with some test data. Yeah. So I'm going to go ahead and give some input and say const. Same thing that we were working with. I hope I have it somewhere here. Okay. First row was 9, 8, 9. And second row is 3, 3. And finally we have 15 and 15, right? 15 and 15. Okay. So I hope this is going to fly. Otherwise, we have to run into a few debugging steps. Okay. So I'm going to say console block. Okay, find pairs. And it's going to equal, and it's going to get the input here. Okay, let's give it a shot. Okay, node find pairs matches. Yeah, we get it, but we didn't get the 8 here, right? Interestingly. Ideally, we should have got that. Maybe there is something that's missing here. Hope we are using it right. Got return? Return what? We're returning here, right? Okay, maybe I'll check this one. Unmatched. Okay, you're saying something, function. So, what was that? Okay, unmatched, and also want to check what is coming back from here. Back from here, right? So, one part, and I also want to check what's coming back here. There is the might be some typo somewhere here, I'm thinking. Okay. Alright, so let's actually run this again. Didn't produce that. It's not even going there. Oh. Okay. So it's not even getting this one back, interestingly. Find pair. Okay. Right. Should have given us something. Matched pairs. Matched pair. Let me actually do a console log here. Turns out it's not even coming here. Let's do this. Pushing to unmatched. Okay, it is definitely pushing. Matched pair and unmatched pair, but why is it not coming here? It should be actually. Hold on. Why is it not coming here? Oh, okay, it is not else. It has to be another if by itself. Okay. What's wrong? Here. It's not an else. It's an impulsive else active. So I should actually say if I have another if there. and say unmatched length is greater than 0. I have to do this. Now it should work. Okay. Yeah, there we go. We got it this time around. Okay. All right. So coming back to the complexity here. So here we are processing each row, and each row is being in turn processed, right? So this is going to be m by n at least, right? At least m by n. So for example, we are processing each row, and inside each row, we are doing a find pair, right? So for example, here we are processing each row, and each row we are finding a pair, right? So if let's say we have m rows, and each row has n elements, right? We are going over the entire m by n elements, right? So that's going to be at least m by n, right? And if I go inside of, let's say, find pair, right? If I go inside of find pair, which is going to be processing each of the rows, I am, yeah, I think that's about it. Actually, m by n is what you do, right? Yeah, m by n, and then you actually go through the object here, the keys, paired items, which is pretty minimal. I don't expect the paired items to have a lot of elements. So it is m by n, I would say. Right? What do you think? Is it actually sounding okay? Sounding good? Any thoughts? Any comments? Okay. So this is our second problem. Anything that you want to add here? Okay, sure. Why not? So you want me to explain through the code, or you want to go back to the drawing board and then map it to the code? From code. Okay. So essentially, if you go look at the code, right, we have the main method or main function, which is essentially called find pairs, right? And this is going to get the matrix. And what will the matrix contain? The matrix will contain data like this, right? It is going to be a two-dimensional array, and each row would contain one shoe box, right? And where one would be the odd one out, right? Which is going to be the unmatched number, right? So each of them the matrix would contain a number of rows, right? Okay. So so essentially, our main function will get that matrix, right? From here, we will process each row, right? So we will take the first row from this matrix, right? And then pass that row to another function, which is called find pair, right? And from find pair, we get a matched pair and the one shoe which is unmatched, okay? And both of them will be erased, right? So if the matched pair is greater than 0, we actually push it to one of the outputs that we are returning, which is going to be the matched pairs, right? We essentially register it in that particular, or push it to that particular array, okay? Similarly, if there is an unmatched shoe, we also keep track of that particular shoe by pushing it to the unmatched pairs here, right? So by the end of this for loop, we would have processed all the rows in our matrix, right? So we have matched pairs and unmatched pairs as well. Okay. All right. So what happens now? We have matched pairs, all right, but we also have a bunch. We might also have a bunch of unmatched pairs as well, right? We need to essentially repair them, correct? So in order to do that, we actually go ahead and then process the unmatched pairs here. okay? And then push it, and then call the find pair again on that unmatched pairs array. And finally add that result to the matched pairs here, then return that matched pairs. Okay? All right. Okay, great. That's good to know. So we can go to the next one right now. So the next problem is going to be, let's take a look. So the average time, right? So this is about keeping the average. So how many of you use smartwatches? You folks use smartwatches? You don't? Okay. Anybody uses smartwatch? So if you use a smartwatch, I'm sure you'll be tracking a lot of data there, right? So it could be your blood pressure, or it could be your, let's say, oxygen levels, or for that matter, let's say, I don't know, some of them actually keep track of a lot of interesting data actually, right? So it could be the number of steps you would have taken. Heart rate is another one, right? And sleep, yeah. And you essentially, you can actually create a lot of data from this one, right? For example, your heartbeat could be collected over, let's say, 15-minute period or 10-minute period or something like that, right? And you may want to find out, let's say, the first 10 minutes it was actually the heart rate was X. At the second interval it was actually Y. Third interval it was Z, and all that stuff. And you want to find out the the average of that, right? So you essentially get all the heart rate, the entire range, and then find the average, right? So the third problem that we are trying to essentially um, solve is something on the similar lines. Okay, so it is related to an athlete, and she is actually participating in some race, and she wants to calculate the average time taken. So she actually does a lot of practices. She goes through multiple sprints, and she wants to find out the timings from those sprints and then find out the average. Okay, so that's what is the problem here. Okay, so what is the input that we're getting here? We are getting a 2D array, right? And first number is the start time. The next number is the end time, right? So for example, if you take the difference here, the time taken here is 5 seconds, right? So let's say we started at 3 seconds and ended at 8 seconds, right? The time taken here is 5 seconds, right? Similarly, if you look at the second number, the time taken here is 4 seconds, and here also it's 4 seconds, right? And if you want to take an average, that would be how much? 5 plus 4 would be 9, plus 4 would be 13, and divided by 3, and that would be 4. I don't know if that's 4. I think probably this is incorrect in my opinion, right? So 5 plus 4, 13, plus 17. Okay, it's actually 4. I got it is 4. Right now, it is an integer. It could also be they have omitted the decimals here, something that we can also take a look at as well. Okay, so yeah, relatively simple. I'm sure you would also feel that this is relatively simple, right? Okay, so I hope I don't have to explain it by using the whiteboard here. I'm sure if you look at the code, it'll be a lot more obvious as well, right? Okay, so I'm going to say define another method here. I'm going to call that find average. You haven't got input. The input, okay, let's go back to the slide deck here. So the input here, so will be this input, the matrix. Oh, the output. So let me actually go back to the whiteboard. I think that's going to be better. So we got a 2D array here, right? Correct? So you got a 2D array. So the first number is, she starts at 3 seconds, ends at 8, right? And the second timing is, I think, 4 and 9. And the third timing was 1, starts at 1, ends at 5, correct? Okay, so this is your start time. This is your end time. Okay, so for each of the rows, for each of the timings, we can calculate the time taken, right? So what is the time taken here? It's going to be E minus S, correct? So in this case, this is going to be 5. This is going to be, I thought, okay, this is also going to be 5. This is going to be 4, right? Correct? Actually, what is the data that we got? I think we got 16 from there. So it was 3, 8, 5, 9, and 1, 5. Okay. 3, 8, this is 5. Okay. So this is 4 then. Okay. So, okay, I think, so we have to add this up. So which is going to be 13, right? And so 5 plus 4 is 9, 9 plus 4 is 13, and you divide it by 3, right? And that would be 4, right? If you look at the integer division, of course, we are omitting the fraction here, right? So that's what is the output. Okay. All right, let's go back to the code, the IDE. Okay. I'm going to close these two so we have a clean view. And I'm going to say find average time, right? Yes. Okay. So let me go ahead and code this one up. Say it's going to be an arrow function. So this is going to be an arrow function. I'm going to say find time. Arrow function, and I'm going to get an array. I'm going to call that timings. Okay. So like before, I'm going to go over the array, right? So I'm going to say timings dot for each, right? And we're going to process usual timing, right? So I'm going to say timing. This is going to get a usual timing. What do we do? We need to maintain a couple of things here, right? So I'm going to say let total time total time, yeah, to 0. And say const time taken is equal to, so this one would be an array, right? So I'm going to say timing of at 1 minus timing of 0. Okay, you can also make it something like this, right? So the structuring part. So I'm going to say start, comma end is equal to timing. Okay, and we can then replace it with end minus start, right? And then we can add it to the total time as well. Total time plus equals time taken. Okay, super. Yeah, great, looking good. So we got the total time, and all we have to do is we have to find the average time, right? So how do we do that? We can say const average time equal to total time divided by timings. Length the timings, right? So timings dot length. And we can go ahead and then return this one. Right? Making sense, folks? We can use spread operator again. Where was that? Where can we use the spread operator? Here, line number 9. But if we do that, how will it help us? N minus time for average, we need to add, right? Okay, one at a time. So there was a suggestion we can use the spread operator here again, but how will it help? Okay, I don't know if that can help using the spread operator here, so I just did the destructuring. Okay, what was the next question? Line number 9. Line number 9. Okay, what is wrong or incorrect about that? Do you see any gaps in terms of implementation? Line number 9. Yeah, this is destructuring, right? This is destructuring. Okay, I hope it's all clear right now. Yeah, we are adding here, by the way. There was a question whether it's subtract. We're doing subtract because we want to find the time taken. Adding will be here. Okay. All right. So we can go ahead and give it a test run. Which one got confused? Subtract part. Okay, that is actually, we need that to find the time taken, right? So for example, if I have some data like this, right? Let me go back to the place where we have the data. So we have this data, right? This is our row. The 3 is the starting time, 8 is the ending time, right? We get the actual time by subtracting 3 from 8, correct? That's what we're doing here. That's what we're doing here. Okay. All right. Super. And okay, let's actually and then give it a shot. So I'm gonna say const input and do a two-dimensional array. Okay. So we had 3, 8, 1, and so I had 4, 9, I think. 4, 9, yeah, that's true. And 1, 5. Super, and let's go ahead and call this one. Let me say console dot log, and it's going to be which time, and that's going to be input. Okay, and let's go ahead and then run this one. Let's say node find average time. There we go, and it's giving us some decimal values, and which means we need to go ahead and then get some fixed decimal in output. If we do this, it should give us, yeah, 4.67. That's going to be the average time. Okay. All right. Looking good, I think. I think this was simpler of the lot. I don't think we had to relative terms. It was simpler, right? Okay. Okay. Let's go to the next one, next problem, and check what we have here. So continuing on, we got the average time sorted out. And then we have the next problem, which is the special positions in a boundary matrix, right? So what is a boundary matrix? It would have only zeros and ones as values, right? So, so essentially, we want to find out special positions in this boundary matrix. So we are given an n by n matrix, right? And return the number of special positions in a matrix, right? A special positions something where a matrix or at index ij is 1 and all the other elements in that particular row and column are zeros, right? So if I go back and look at the example to understand this better, so in this particular case, right, let's take this example, right? So 1 0 0 0 0 1 and 1 0 0. Okay, let me go back to the drawing board. So we are given a boundary matrix, right? So boundary matrix, as we mentioned, is having either ones or zeros, correct? So our data looks something like this: 1 0 0, right? And other one was 0 0 1 1 0 0, right? So this is our matrix. Okay. So how do we call? So essentially, we want to find those special positions. So what is a special position here? A special position is something where the value is 1, right? And that element happens to be the only one in the corresponding row and the corresponding column, right? So if you look at it right now, if you consider this one, right? So right now, this is index 0, 0. This is 0. Let me go ahead and do the indexing bit as well. Oops, no, no. This is index 1, which is a row, and this is the index 2, which is third row. This is going to be index 1, second column, and this is going to be index 2, third column, right? So right now we are at 0 0 and it's a 1. So the question here is that a special position? So in order to do that, understand that, we have to check if there are any other ones in the row, right? Right now, if I go to my right, there are no other ones here. All of them are zeros, right? So which means we can potentially say this can qualify to be a special position. However, we also need to look at the column right now. So if you look at the column here, we see that the second row in the same column is a 0. So it's looking promising. If we go to the next row, which is the third row in the same column, it is actually a 1, right? Which means the 1 is repeating in the same column, right? So which means this position is not a special position, right? We can strike this one out as not a special position. Similarly, let's go to the next one, right? The next one is actually in the second row and the third column, right? So if you look here right now, if you focus on this particular element, this is a 1. If you look in the corresponding row, there are no other ones, right? So essentially it can potentially qualify to be a special position, right? So which is, so this is right now 1, which is second row and third column, 1 comma 2, right? Similarly, if you look down this particular column or up this particular column, there are no other ones, right? So which means it can qualify as a, it will qualify as a special number, right? This is definitely a special position, not number, special position. And if we go further down in the last row, we have another one here. However, for this one, there is already a 1 here in this column. So this cannot qualify to be a special position. So right now we have only one special position, that is at row 1 and column 2, right? So that is what we need to find out. Let's take another example. So for example, I'm going to say 1, 0, 0, 0, 1, 0, 0, 0, 1, right? So in this case, 1 is, we found a 1, right? So potential for it to be a special position. We look to the right, there are no other ones. So essentially, it is potentially a special position. We look down, right? There are no other ones. So yes, this is definitely a special position, right? 0 and 0 is a special position, right? Similarly, if we go to the second row, we find that this element is a 1, right? And if we look at the row, there are no other ones. If you look at the column, there are no other ones. This can qualify to be a special position, right? So which means this is going to be 1, comma 1. It's going to be a special position. You look down below to the next row and you find a 1 here, right? And you look up and look to the left, there are no ones. So obviously this also qualifies to be a special position, and this is going to be at the second row and the second column. So right now we have 3 special positions in this particular matrix. Okay, so that's what we need to essentially look at and you know look at the array and find out the number of special positions here. I think that is the ask. I think if I look here, yeah, we need to find the number. We could also find we can also return the positions also, but here they've asked for the number of special positions. Okay, any questions? Are we good to go? Are we good to go? Okay, super. So let's go back to the IDE. Okay, so in here, I'm going to go ahead and then introduce another file, and we call that special positions, right? So I'm just going to find special positions. Okay, here we go. So here, I'm going to define another method. That's a function, an arrow function. Let me collapse the sidebar. Let's say const find special positions. And I'm going to keep it concise. Right, and this is going to be an arrow function. Okay. And what is it going to get? It's going to get a matrix, right? So essentially a matrix, a boundary matrix to be precise. So I'm going to call that matrix, or we could also call it an input, right? Okay. So what are we going to return here? We're going to return either the number of positions, right, or the entire result array itself, which is the positions where there are special positions, right? So we can do either of them essentially. Okay. Give me a moment here. I think an issue with my screen. Okay, there we go. So to begin with, I'm going to define a result here, right? Which is going to be the positions themselves, right? So I'm going to say const result is going to be an array, okay? And I'll also, so the question here is that how do I actually solve this problem, right? How do we solve this problem, right? So I'm going to go back to the drawing board here one more time so that, I essentially discuss how we can actually go ahead and solve this problem, right? That's going to be important because once we have the concept clear, it's easy to essentially put that into code, right? I'm going to go back here and then explain that bit here, okay? Okay, so if you look at this right now, we're going to go over each of the elements, right? So we're going to say if this, let's say we scan through the entire array, right? We will keep track of the special numbers or special positions, right? So we can say we found a special position here, and let's actually keep track of this one. So we can essentially record this here, and we can create a key for this one, and the key would be the position of the column and the row. So in this case, the key would be 0, and I'll also introduce a 0, right? 0 underscore 0, and that is going to be equal to 1, right? And this is going to be our object, right? Likewise, we will go through the entire array, right? And then whenever there is a 1, we will record the key, which is going to be a combination of the row. This is going to be the row, right? And this is going to be the column. And then we'll record that as a 1. Okay, all right. So likewise, so if we go through this array, what do we get? We go to the first element, which is 1. So right now we got 0 underscore 0 as 1. We also got to the second row, and here we found one position where it's a 1, and it is coming in at the first row and the second column, right? So essentially we're going to say 1 underscore 2 is 1, right? Okay, and then moving on, right? So let's go to the third row here. So the third row, we find that there's another 1 which is going to be coming in at the second row and the 0th column, right? This is going to be equal to 1, right? However, remember, we already have a 1 here in this column, right? So every time we encounter an element where the column, right, this column is matching with any of the other columns here, then we cannot add that, right? We need to essentially not add this. We also need to get rid of this one as well. Okay, so eventually we will end up with this answer only. Okay, so because 0 and 0 is common here, we cannot add this to the final result, correct? So we will end up with an object, or the special keys object, so to speak, okay, that says 2, I'm sorry, 1 underscore 2, 1 underscore 2 as 1. Okay, so finally the result could be either of this, right? So it could be that the length of this particular object keys, right? So we can say the keys, the length of the keys is obviously only 1, right? Or we can just return the keys as an array of all the positions which are considered special positions, right? Either of them could be fine here. Making sense, folks? The key here would be this one. How do we form the keys, right? So do you know why I choose an underscore here? Okay, the reason is that, so for example, let's say this is a bigger array, right? I mean, in this, it may not happen in this particular case. Let's say there is a bigger array, right? So something like, so let's say a bigger array, right? So for example, you're looking at let's say 12th, how do I explain this? First row and 23rd column, and so there might be collisions if we don't do this right. There might be collisions. So that's why I have to introduce this. I will actually come back to you in terms with a valid example, but if we don't do this, there would be collisions in case of bigger arrays. Okay, so that's why I had to introduce this. So for example, let's say first row and 12th column, right? Okay, and 11th row and second column. Both of them would have the same keys. Oh, I'm talking about this underscore. Underscore in the key. So let's say first row and 12th column, right? So if I had to represent this as a key, if I do this, right, then they would be individual keys. So I can represent 11th row and second column like this, first row and 12th column like this, right? That's why I had to use the underscore. Important to know, because otherwise there would be a clash there. There would be a duplicate entry, and then obviously that would result in some processing result, right? There would be a fault or incorrect processing of your data. Okay, so that's why I had to introduce this underscore here. Okay, so that would be the key, and yeah. So any questions on this, folks? We want to make sure that we understand this particular thing the way we are doing this, and move forward. Are we clear with how we are processing this? Okay. So what would be the complexity here right now? What would be the complexity of this one? Any idea? From time complexity or? Okay, I would put it as m by n, because I think we're looking at an m by n matrix. So order of m by n, right? This is going to be the time complexity. Space is order of how much? Space. Order of n, which is the number of rows, you mean? When you say n, what do you mean by that? The number of rows, or? What is n here? So we have m rows and n columns, right? So are we saying space complexity is order of n, which is the number of columns? Okay, actually the space complexity, as there was another answer here from Joseph. So that's actually m by n, the worst case, right? The worst case, every element could end up being 1, right? Okay, so in which case our this object, the key, where we're maintaining the keys, would be um, m by n, right? That could happen potentially, right? SC space complexity. Yes, space complexity. That's what I meant. M by n would be m by n. Worst case, right? Because potentially all elements could turn out to be 1, right? In which case we would be essentially populating this key object. Again, it also depends on how we process it, right? Let's say if we find that there is already an existing element, we might take it out, right? So in which case it may not reach m by n, in my opinion. Depends on how we actually process it, how we process the data, and how we essentially implement this, right? If we end up implementing it in an n by n space complexity, it might turn out to be that, but it might turn out to be less than that as well, right? So, but anyway, there is some space complexity involved, but might be negligible in my opinion. Maybe, yeah, I don't think it's going to be a whole lot. Okay, it would, but the major thing here would be the time complexity, which is going to be m by n, because we're going to go through the entire array, right? We're going to scan through the entire array elements, so that would be m by n for sure. Okay, so that's about the kind of conceptually how we can go about doing this. I think this is going to take another 15 to 20 minutes. I'm thinking we would be better off doing this in the next class. That way, we will be fresh in terms of um, following this. Otherwise, it will be a lot of stuff covered in this, and then it'll be difficult for us to retain this. So how about this? We will actually go ahead and then we'll go ahead and do this in the subsequent class, and then continue with this particular problem implementation, and then take up the next problems as well. Okay. Yes, the core. I will figure out a way to actually share the code, right, and then share that with you guys. Okay. All right, everyone. Hope you had a good time. Hope you enjoyed this session, and thank you for keeping it engaging and interactive. And have a good rest of the evening. We'll catch up again on Wednesday. Wednesday, same time, 8 to 11, right? Okay. All right, then. Take care. Bye-bye. Thank you, everyone.